8x equals 12, and then I divided both sides by 8 and got x equals 1.5.
Very good. I would have you, if you divided both sides by 8, leave it as a fraction, okay? So we're just going to simplify that fraction. 12 over 8 simplifies to what?
6 over 4. Oh, no.
Yep, 6 over 4. But that also simplifies to?
3 over 2.
3 over 2. Or 1 1/2. Very good. Now, the reason we got 8x equals 12 is because we cross multiplied. The 8 gets multiplied to the x, and the 3 and the 4 get multiplied, and we set them equal to each other, okay? Let's do number 4 as well. Someone other than Teresa, walk me through number 4. Nico, let's go. What do I do? David? Marcos? So, how do I write it?
15x?
Not quite. I agree with your idea to cross multiply. So this is going to be 5 times x plus 3 equals, what's the other side? Yes, 2 times 3 or just 6, okay? What do we do with the 5? Distribute it. So this is going to be 5x plus 15 equals, and just like Noah said, it's 6 over on the right. Kale, how do I solve this? What do I get? Yep. It's the same as -1 and 4 over 9. Section 1, let's do this. Okay, corresponding parts of similar polygons. So, corresponding angles are congruent and corresponding sides are proportional. So if we say that ABCD is similar to MNOP, then angle A is congruent to angle M, angle B is equal to angle N, angle C equals angle O, and angle D equals angle P. Okay, up at the top, I need you guys to write a squiggly like this. This is the similar symbol, okay? So whenever you see that symbol, it means that two things are similar, okay? Now, do you remember when we were talking about congruence, how it mattered which order the letters were in? Same thing applies to similarity. So, see how this is ABCD is similar to MNOP? That means that A matches up with M. B matches up with what? N. Oops. N. C matches up with?
O.
And D matches up with?
P.
Beautiful. Okay? Same thing applies when we're talking about similarity. Now, all of those angles are equal, but their ratio or their proportion or their fraction of their sides is all going to be equal. So if we took the fraction of AB over MN, that's going to be equal to BC over its corresponding side, which is NO, CD over OP, and AD over MP. Now, let's check it out. Let's say AB was 8, MN was 3, NO was 4, MP was 4, 8, I'm sorry, not 8. AB should be 6. Erase that. AB should be 6. 8, 8, 10, and 5. Okay? So AB over MN. AB is 6, MN is 3. 6 over 3 reduces to 2 over 1. BC over NO. BC is 8, NO is 4. 8 over 4 reduces to 2 over 1. CD over OP. What's CD? What's OP? 10 over 5 reduces to 2 over 1. And our last one, AD over MP. AD over MP. What's AD? What's MP? 8 over 4 reduces to 2 over 1. See how our scale factor was the same throughout? It's 2 over 1 for each one, okay? That is how you know that two figures are similar. If each of their sides are proportionate, so they each have the same proportion. Now, did you notice that like AB, BC, CD, and AD were all the numerator, right? They all belong to this first figure, okay? And the denominator all belong to the second figure. You have to maintain consistency when you're doing that, okay? You cannot put M or NO over BC, because when you flip it, it's not going to be the same scale factor, okay? All right, moving on. If two polygons are similar, the ratio of corresponding sides of two similar polygons, that is what we call the scale factor, okay? It's also known as a simplified ratio. And pay attention to the order of the letters. Okay? So let's imagine that ABC and DEF are similar polygons or similar triangles, okay? If they're similar, then each of the relationships between the two sides should be the same ratio, okay? So let's take ABC to DEF. And let me get a zoomer. Kevin, Pardo, give me any side from ABC. Kevin, give me any side from ABC. Bye, Kevin. Samantha Nieves, give me any side from ABC.
BC.
Okay, BC. What's the corresponding side in DEF, Samantha? Yep. EF. Very good.
Oh.
EF. Yep, you both are right. Okay. Now, always check that your letters match up. So we picked BC, right? Does that match up with EF? Yes. They are both the last two letters. Do you guys see that? They have to match up. Just like we did with corresponding, those two have to match up. So let's write our ratio, okay? Our ratio is going to be BC over EF. What's BC? 3. What's EF? 6. We get 3 over 6, which is 1 over 2.
I have a question.
Go ahead, Teresa.
So, would it, like, I'm not sure if you already mentioned this or not, but would it make a difference if you would put, like, CB over FE?
No.
Okay, but it does make a difference. I don't remember what you said that you can't do. Can you repeat that, please?
So, like, let's say we wrote EF over BC.
You can't do that?
No, because we're comparing ABC to DEF.
Okay,
Now,
so you have to go in the order of like what it's asking for?
correct. Yep. So if it wrote that ABC is similar to DEF, always put this one as your numerator, always put this one as your denominator.
Okay, got it. Thank you.
Numerator, denominator. Okay? And then that way you're always consistent. So you would never write EF over BC. Do you see? Because that would just screw up your scale factor and you would get all messed up. Okay?
Okay. Thank you.
Mm-hmm. All right, now let's say, for Teresa's sake, let's write DEF is similar to ABC. Pick any side other than EF in the second figure. Justin Torres. Yeah, what's up?
Kevin said that like you couldn't hear anything, and like he was asking me why you kicked him out.
Can you repeat the question?
Like, that he couldn't hear anything.
Okay. Justin, pick any side other than EF in the second triangle.
DF.
Okay, DF. Nico, what's the corresponding side in ABC to DF?
In ABC to DF.
Mm-hmm. So DF is the side that we picked from the second triangle. What's the corresponding side in ABC?
AB.
Nope. AC. Why, Samantha?
Because they're both the first one and the last.
Correct. Always look at the letters. See how D and F are the first and the last? It must be AC in the second one, okay? Now, Teresa, since we wrote it in the opposite direction, we're going to write DF as our numerator now, okay? So DF over AC. Oh, don't forget to highlight that side on the other triangle, okay? So DF over AC. What's the measure of DF? Noah?
6. Oh, sorry.
6? No, you're good, Teresa. What's the measure of AC, Teresa?
3.
3. So now our ratio is not 1 over 2. What's it going to be? 2 over 1. What do we notice about when we flipped our similarity? When we wrote the similarity in the opposite direction, what happened to our scale factor? You flipped it, right? Or you found the reciprocal, okay? So your reciprocal is always going to happen when you switch your similarity. So if you were ABC to DEF, is going to give you 1/2. You switch the similarity, you should get 2 over 1.
But when you get the reciprocal, wouldn't it be negative 2 over 1?
Nope. So that's opposite reciprocal.
Oh, okay. Okay.
Okay?
And they would still be considered similar because they're the reciprocal like
Yep.
of each other.
Mm-hmm.
Okay.
But our scale factor changed. Do you see that? So your scale factor depends on which way you write it.
Okay.
Mm-hmm. Now, if you were to look at ABC and look at DEF,
Correction, Angelina Gravalia, report to student services. Angelina Gravalia, report to student services. Thank you.
wouldn't you say that each of the sides was doubled? To go from 3 to 6 for each of the sides? That's why our scale factor is a multiple of 2. It's 2 over 1 for DEF, so DEF is double whatever AC is, ABC. And then from ABC to DEF, it's 1/2. It's half the size of DEF, okay? That's another way to look at it, so you can check yourself. All right, moving on. Example 1. So we're going to find the scale factor of ABCD to MNOP. Find the scale factor of ABCD to MNOP. KL, how am I going to find the scale factor? AB is equal to, very good. AB over MN will give us our scale factor. But do we know what MN is? No. So we have to start with the two sides that we know and are corresponding. Which two are they? Very good. AD and MP. Okay? Because this one's 10 and this one's 8. Do those match up in our similarity statement? I'm sorry. It was AD and MP. Yes, they do. Okay? The first and the last, the first and the last. So we're good. Let's write it AD over MP. What am I going to get? 10 over 8. That simplifies to what, Noah? 5 over 4. Excellent. What do we just find? Good. That's our scale factor.
So you only need to find it for one?
Correct. You just find it once. Now, we have to find X, Y, and Z. In order to find X, Y, and Z, we have to use that scale factor. That scale factor is going to be consistent throughout each of our sides. Okay? So how do we find X? What would we do to find X? Yep. So BC over NO. BC over NO equals, you said 4 over X, very good. 4 over X. And we set that equal to, David just said it, 5 over 4. It has to be equal to the same scale factor, okay? We use that scale factor and we solve this. This is going to be cross multiplied. So we're going to get 5 times X and 4 times 4. This will be 16 equals 5X. We divide by 5. Divide by 5. And we're going to get X equals, does 16 over 5 simplify? No. But how many times can 5 go into 16? 3. And what's left over? 1 over 5. So 3 and 1/5. Let's find Y. How do we set it up to find Y? 12 over Y equals? Yep. 12 over Y equals 5 over 4. What do I get when I cross multiply? (5y) equals 48. divide by 5, divide by 5, y equals, let's simplify 48 over 5. Well, it doesn't simplify, but yes, we can take out a 9. Goes in 9 times. What's left over? 3 over 5. And
When we're solving this, do you want us to put the answer like as a mixed number, or can we leave it as the other fraction, like 48 over 5?
you can leave it, but I'm doing that because it's going to ask us to find the perimeter. It's much easier when there are mixed numbers to find the perimeter, okay?
Okay.
But you can leave it, like, if this was a quiz or a test, you could leave your answer like that. That would be fine, okay?
Okay.
All right, and let's do Z. Someone set it up.
So in the homework, can you do that also?
How would we find Z?
BC and
14 over z equals 5 over 4.
Which is 14 over Z equals 5 over 4. Excellent. Let's cross multiply and figure it out. What am I going to get? 56. Divide by 5, we get Z equals 56 over 5, which simplifies to 11 and 1 over 5. So we found X, we found Y, and we found Z. We found X, we found Y, and we found Z. Okay, this is the fun part. Find the perimeter of each. What's the perimeter of the first one? 11 and 1/5. What's the perimeter of the first one? Good, 40. 10 plus 12 plus 4 plus 14 equals 40 units. What's the perimeter of the second one? Well, we got to calculate it. So it's going to be 8 plus y, which is 9 3/5, plus x, which is 3 1/5, plus z, which is 11 1/5. What am I going to get? Ooh, 32. Okay, and then the last part of this question is find the ratio of the perimeters. The ratio of the perimeters. Now, before we find it, what do you guys think it should be equal to? 5 over 4, okay? The reason it works is because if you added all the sides together and found the ratio between them, it would also be equal to the scale factor. That scale factor holds for perimeter, okay? So let's take 40. Let's put it over 32. How do we simplify this? What do we take out from the top and the bottom? Yep, divide by 8. Because that's the greatest common factor. So then this would be 5 on the top, and this would be 4 on the bottom. You could have divided by 2 and kept dividing by 2, like 3 times. But if you recognize the 8, just use 8 to begin with.
Is the ratio of the perimeter always going to be the same as the scale?
The ratio of the perimeters will always be the same as the scale factor. So this is actually a theorem, okay? I just wanted to prove it to you guys. So we just went through every single step. You guys don't have to do this in the future, okay? You guys can just know that the scale factor will always be the same for the ratios of the perimeters, okay? All right. We're gonna do one more example, and then we're gonna talk about those theorems, and then we're almost done. Okay. Corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. Please underline two corresponding lengths. So in this case, it's telling us that TPR is similar to XPZ. Find the length of the altitude. So the altitude is not a side, it's just a length of the triangle. But that, since it's a corresponding length, it is going to be similar as well. So it's going to follow the ratio of the scale factor, okay? So we need to use two of the sides that were given to figure out the scale factor of the two triangles. What do you think we do to figure out the scale factor? Anyone? Well, in TPR, which side are we given? TR. And which side are we given in XZP? XZ. Are those corresponding? Why? Very good. The letters line up. T and R are the first and last, right? X and Z are the first and last. Very good. So let's find our scale factor. What was TR? Don't say 6. 12. What's XZ? 16. Is that hard to see? Is it better now? Okay. Does that simplify? 3/4. So this is our reduced scale factor, okay? You always want to simplify your scale factor. So we're going to use this to come up with whatever PS is. Let's assign X to PS just so it's easier for us. So 12/16 gave us the 3/4. So we're going to set this ratio equal to 3/4. So we're going to set it as X/20 equals 3/4. And we're going to solve. So we cross multiply, we get 60 equals 4x. And we divide by 4, we get what? X equals 15. So the length of PS equals 15. So the reason this example was important is because PS is not a side of your triangle, it's the altitude, okay? But all parts of that triangle are congruent. So the altitude, the height, the base, whatever you were finding, those are all going to be corresponding. Those are all going to have that same ratio of the scale factor, okay? About our two theorems, one example, and then we're done. Theorem 8.1, the perimeters of similar polygons. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. In other words, the scale factor. So if two figures are similar, if you added up all their sides and divided by the perimeter of all the other figures' sides, that same ratio would hold for each of the sides individually, okay? We just looked at this in our other example. Area, it's not the case, okay? Area is a little bit different. So the area of similar polygons. If two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So you take the scale factor and you square it, and that will be equal to the area, the ratio of the areas, okay? So let's say we had a ratio or a scale factor of 1/3, and we squared it. This would be 1 squared over 3 squared, which is 1/9. Let's say we had a scale factor of 3/4, and we squared it. This would be 3 squared over 4 squared, which is 9/16. Okay, last example, guys. The ratio of the areas should be equal to what? The scale factor squared. That involves this area section, okay? In the diagram, GHJK is similar to LMNP. Find the area of LMNP if we're given the area of GHJK is 84 meters squared. Okay? So, first off, we need to find our scale factor. Marcos?
3/4?
Nope. 1/3. Okay? Now let's figure out how Marcos got 1/3. Well, I see that we're given KJ, right? Or JK. What's the corresponding side to JK? NP. NP. Do you guys see that? It's the last two letters of the first figure. They match up with the last two letters of the second figure. So, we're going to write the expression JK over NP. This is for our scale factor. Once we get this, we're going to get 7/21, which simplified is 1/3. Okay? So our scale factor is 1/3. Now, the ratio of the areas is not going to be equal to 1/3. What's it going to be equal to?
84.
That's the area. So the area of GHJK over the area of LMNP. Now let's take a look at the slide before. So we're just going to take the 1/3 that we got and square it. Now we know the area of GHJK, Teresa just said that, it was 84. So we're going to write this as 84 over, since we're finding the area of LMNP, we're just going to substitute x for it, since that's what we want to find out. And we'll just solve for x. Equals, what's 1/3 squared? 1/9. Very good, okay? You square the top, which is just 1 squared, so that stays as a 1. And you square the bottom. So the 3 would get squared and you would get 9 on the bottom. Now we just cross multiply. We're going to get 84 times 9 and x times 1. So we get x equals 756.
756.
Meters squared. So that is our area of LMNP.